Just for wait for 2 minutes. Okay, in the last class, we discussed about the do and do while and while loop. Today we'll go for the for loop. Basically, for loop in a C language is used to iterate the statement or a part of the program several times. It is frequently used for the concept of the data structure like the array and linked list. Then we'll go for an array. So we'll go in detail to that things. Okay. General syntax of the for loop is for within the open and close brackets, expression 1 semicolon, expression 2 semicolon, expression 3. After expression 3 there should not be a semicolon. After the expression 3 you should not have a semicolon, followed by open braces and code to be executed close braces. This is a general syntax for the for loop. A flowchart. In the flowchart, in this flowchart, we'll have a initialization. First, initialization part. Initialization part. Then say I have a I equal to 1. It is called the initial part, initialization part. Then followed by the condition. Condition is say I is less than or equal to 10. It is called the conditional statement. After that, you have a body of the instruction to be executed. That is for the if the condition satisfied. If this condition, test this condition, that is expression 2. If this expression 2 is a condition, if condition satisfied, go to the statements below the for loop. That is a body of the instruction need to be executed. After the execution, it goes to the expression 3. Generally, this expression 3 will be a general format in a mathematical evaluation. In generally, we're going to use increment or decrement operation. Generally, I plus plus, I plus plus, okay, I minus minus, like that we're going to use. After this operation, it will go back to the after increment or decrement, it will go back to the testing the condition. That is, it will go back to the condition, that is expression 2, test the condition. Then if condition true, go to the same process. If condition false, skip the statement, body of the statement below the for loop. Okay. For example, say the previous thing, it is a table 1. Initialized with an I equal to 1. I equal to 1 and here say I equal to initialized I equal to 1. It is the expression 1. After the expression 1 semicolon, then I equal to I less than or equal to 10. It is called the conditional part. Then it tests the conditional part. After that, it goes to the body of the instruction below the for loop. That is a print print percentage d backslash n I. I is the initially I equal to 1. Then it go back to the expression 3. Expression 3 is the I plus plus. I plus plus is initially I equal to 0. Here initially you have been mated initially I equal to 0. Then initialize, that is I int I equal to 0. It is for the defining a variable. It is an integer type, defining a variable integer type. Then in the for loop we have been defined initialization part I equal to 1. Then in the expression 2 it is for the conditional, and expression 3 is for the increment slash decrement. Okay, here after the conditional test it print the percentage d, that I equal to 1. Then it go to the increment operation. I is initially 1 and it is goes to the I equal to 2. Then it tests the condition. After this operation it will go to the testing the condition. If condition is true, go to the print operation. If condition is a false, failed, then exit from the loop. Okay, here the print 2 till it will be printed up to 10. Once I becomes 10, increment I by 1 is 11. 11 indicate that I is not less than, that is 11 is not less than or equal to 10. For this condition, this is a condition, it is a false condition. When false condition comes, it will not going to execute these instruction, whatever the body of the instruction present below the for loop. It goes to the return. It is an output of that program. Simply, as we have been noted the general program for the printed table of a given number. It's a program for a given number. Whatever a given number is entered, that number has to be taken into the account. Here, in this case, just say I have initialized I have been defined a variables I equal to 1 and the number equal to 0. Is an option. If you are defined just number, then enter a number. Printf, it prints on a screen, enter a number. The number has been stored, load into a variable name number. For example, I have entered a number 5. I have entered a number 5. This number 5 will store into the number. Then I have initiated I equal to 1, I is less than or equal to 10, I plus plus. In this case, print percentage backslash n number into I. I is the initially I equal to, number is 5, I equal to 1, which is equal to 5. Similarly, it will go for the increment operation. I is initiated with 1, increment by 1 means I equal to 2. Then test for then it go for the testing a condition. That means condition is true. Condition true means this print statement will be executed. That is, number is fixed. Number is 5. Only the varying thing is I. Here number into I. It will display number into I. Number is 5. I is 2. That which is equal to 10. 10 will be displayed on a screen. Up to till it will goes to up to it gets the I equal to 10. Then automatically 5 into 10, which is equal to 50. This only these things will be displayed. That is 5, 10, 15 like that. It will be displayed on a screen when you have entered a number 5. Okay, this is a general table, general program for the a table showing the program showing the print a given number, table number. For example, you have entered 2, it is an output. This 2, 4, 6 like that, it will be outputted on a screen. Okay, here the general properties of the, what are the properties need to be considered for a total in a for loop. Total 4 expressions are there. So 3 expressions are there. It is expression 1 semicolon, expression 2 semicolon, followed by expression 3. What should be the properties are need to be considered when we are defining that particular expression? Okay, here expression 1. Expression 1 represents the initialization of the for loop. First part, it executes only one. It is initialization. It is a, when it starts, it is initialize the variables. That variable have to predefine. That is already we have known that int I is a variable. Variable should be defined previously. It should not be defined within the for loop. So we can initialize more than one variable in expression 1. Okay, in the initial case we have defined only one variable I equal to 1. We can also use the more than one variable, that is I equal to 1 comma j equal to 1. In this case we have defined 2 variables. Okay, a number of variables can be defined in the expression 1. That variable should be previously it has to be initiated. This the variable has to be defined previous. Initialization can be done within a loop. Okay, expression 1 is an option. We may use, may not be used. It is not a matter. Okay, after that in say we cannot declare a variable in expression. That is, variable I cannot be defined declared in a for loop. That should be previously. That is, we should be defined that variable. Then that variable can be initialized in the expression 1. However, it can be exempted in some compiler. We may use, may not be used. It is exempted. For example, in this case, we have been used, say, if 3 variables have been defined here: a equal to 0, b equal to 12, and c equal to 23. Then in a condition, only one conditional statement is there: I is less than 2, then I plus plus. Okay, here in this case, first it is initialized only once. In the initialization part, this entire part will be executed initially, starting point only one time. That is I equal to 0, b equal to 12, c equal to 23. It has been called the initialization. Here we have been defined that variable. Int is an integer type. A, B, C. There are the 3 variables. We have been initialized, defined, previously, declared, previously. Then that declared variable can be used for the initialization. That is I equal to C, I equal to A equal to 0, B equal to 12, and C equal to 23. Okay, once you have, it is in a one time, it is execute this entire initialization will execute single time, only one time. The variable defining the initialization between one variable to another variable by using the comma. It has to be used a comma to differentiate one variable to another variable. When you use it more than one variable, only one variable, after variable semicolon. After the ending the 3 variables, you should use a semicolon, that indicating that variables are ended. The initialization is ending. Okay, here in this case, I is less than 2. Initially, A is less than 2. Initially, A equal to 2. A equal to 0. 0 is less than 2. It is condition satisfied. It will not go to the A plus plus. It go to the print percentage A plus B plus C. A equal to 0, B equal to 12, and C equal to 23. The output is 25. After this 25, it will move to the A plus plus. A is the 0. A plus plus is A equal to 1. Then it tests the condition. It is not less than that. It is not less than 2. For that reason, it will print the same. already a is incremented. That means 26 have been printed on the screen. Then it will go for the increment. It is a 2 is 2 less than 2. It is not the condition satisfied. For that reason, exit from the loop. The output of that expression is 12 plus 23 is 35 and 36. 20 that is not 25. 12 plus 23 is 35 and 36. These two numbers are being executed. Okay. Next, same here. Initially we have been initialized. In this case, we have been took that I has been initially initialized, I equal to 1. It is exempted. It is optional one. If you use initialization is semicolon, we have not initialized any part. Expression 1 is optional. Expression 1 is optional. If you not been use that expression, then you need to use semicolon. After that, I is less than 5, semicolon I plus plus. I first initialized previously 1, that is I equal to 1. I tested with that value. 1 is less than 5. For that reason, go to the print percentage the I. Then it is print the 1. Then you go for the I plus plus, that is 1 2. Next is 1 plus 1 is 2. Then test the condition till it goes to the 4. It will be printed. Okay. If you want print 5 also, you need to use I less than or equal to. I less than or equal to 5, then it prints the 5. Okay, next property 2. Property 2 is the conditional thing, conditional expression. Property 2, that is property 2 is related to the expression 2. Expression 2. First expression 1 followed by expression 2, expression 3. Expression 2 is related to the conditional expression. It checks for a specific condition to be satisfied. Whatever the condition you will give, you test that condition. If that's satisfied, it will be continue loop. If it is not, that is condition is not satisfied, the loop is terminated. Loop is stopped. It will be not execute the body of instruction below the for loop. Okay, expression 2 can have a more than one condition. It is not only a single condition. We can use the more than one condition also. However, loop will be iterated until the last condition becomes false. It will test the first from the, it starts from the left hand side, it ends with the right hand side. It is testing from the testing starts from the left hand side, ends with the right hand side. It tests the condition, starts with the left hand and ends with the right hand. Other conditions will be treated as statements. Okay, expression 2 is also optional. We may not use that condition also. It will not going to it just if you want for one time or one time execution. If you not use that expression, simply initialization then semicolon. If you use one more semicolon, then increment. It will not test the condition at all. The expression 2 can perform the task of the expressions 1 and expression 3. That is, we can initialize the variable as well as update the loop variable in expression 2 itself. Okay, we can pass a 0 or non-zero value in expression 2. However, in say any non-zero value is true, the 0 is false. Okay, by default, if the 1 indicates non-zero value, more than 1, it is a true condition. 0, it indicates a false condition. Simply more than 1 or more than 1, it is true condition. 0 indicates a false condition. Okay, here initially the same program, I equal to I is less than 4, less than or equal to 4, same program. In this case, in the next second example, here we have been initialized that conditional statement. In this initialization, more than one variable have been defined. That see I equal to 0, j equal to 0, k equal to 0. We have initialized the declared the variable I, j, k. 3 variable have been declared. After that, you have initialized I equal to 0, j equal to 0, k equal to 0. you have declared, that is initialized 3 variables and tested 2 conditions. 2 conditions is, one condition is I is less than 4, second condition is K is less than 8, and third condition is J is less than 10. These are the 3 conditions. One condition to another condition, you should use a comma. Comma is being used to differentiate a condition to condition. First, it starts from the left hand side and it goes to the right hand side. The comparison starts from the I is less than 4. If this condition satisfied, it go for the test in the condition 2. Then it go for the, when it is false, I is 4 less than 4. When it is false, it test the condition 2. Then if the K is less than 8, then if condition false, test for the J is less than 10. If this condition false, then only the false statement, that is the loop will be exit. That loop will be terminated when J equal to 10, then only J less than 10, then only the loop will be terminated. That is called the thing called expression 2. Expression 2, more than one condition we have been defined. In this case, more than one condition we have been defined. Here we have not been defined any condition. It is called the infinite loop. The loop should be finite only, finite number of times. Here we are not testing any condition at all. It will move to the infinite loop. That is the same value. That I initially 1, it will be incremented 1, 2 up to n infinite number. It will move to the same thing. It will display the. It will not be terminated. The loop should be. The condition is, when we are defining the condition, it should be the finite number of times. The iteration, the repetition should be defined a proper number of times. It should be defined a finite number of repetitions. It is the loop will move to the infinite. Semicolon. Here there is no condition at all. In this case, here we have used a 2 semicolon. Semicolon for terminating initialization and for ending the expression 2, that is conditional statement. Here there is no condition, semicolon. It indicates that it is not test any condition at all. Simply the loop will be continually executing, that is infinite number of times. Infinite number of times. When you are not, it is if you not been used a condition, it will move to the infinite number of times. Expression 3 is used to update the loop variable. Okay, only it is not only meant for the only increment and decrement. We can use any mathematical expression for updating the variables. We can update more than one variable at a same time. Same time it executes. Here in the previous case, I plus plus, only one variable have been defined. One variable is been updating. We can also use more than one variable. This is also optional. Expression 3 is also optional. It is not, if you not been used, it will not move to the any infinite number of loops. But when you are not been used expression 2, that is conditional, then automatically the loop will be moved into the infinite number of times. Here in this case, say I equal to 10, I equal to 0, I is less than 5, is condition. In the third expression, third one, in the third case, we have been used 2 expressions. That is in the expression 3 to evaluation. That is I plus plus, then followed by j equal to j plus 2. Okay, initially I plus plus, I 0, when it is condition I is 0, 0 is less than 5, this prints the percentage d, I and j. I is 1 and second space 2. Then followed by, then it increment I equal to 1. Then also j is being tested. J is initially j equal to j plus 2. J is 2, 2 plus 2 is 4. It prints the same. I is incremented. Initially 0, 0, 2, then 1, 4, then it will move to the 2, 8, then 3, 2, 6, 4 plus 2, 2, 6, then 3, 8, 4, 4, 10. Once if you increment further by the 1, I is that condition is false, then come out of the loop. The output is 0, 2, 1, 4, 2, 6, 3, 8 and 4, 10. Okay, in the next class, I will go for the some more thing called the unconditional instructions.